For this video, we're going to take a look at using tree diagrams again in order to be able to solve problems of probability that can be organized using a tree diagram. So what is a tree diagram? It's a tool that we can use to help us organize these and or probabilities, specifically when we know some probabilities of an event depend on another thing happening first. So when we get there, you're going to see that there's three concepts we're going to look at. One is when we go down a branch of a probability tree, you're going to see we're going to multiply the probabilities because we want the first thing to happen and the second thing to happen. So it's an and type of rule here. We're multiplying. Sometimes we have multiple branches that are possible that we want. Well, that's when we have to add those branches together because that's an or probability. It could be one branch or it could be the other branch. So that's an or type. So we add them together since they're both possible. And thirdly, you're going to see that we can use these tree diagrams to help us out with something called Bayes' theorem. Bayes' theorem. And that term itself is not as important to us, but it's the key thing when something is given to us, when we have additional information that's given. And we just have to remember that those branches that are possible, that are given to us, they need to go in the denominator, right? And that's the given or conditional probability rule that we learned about. So let's jump into one of these examples. It says, Shamil has a flight to catch on Monday morning. His father will give him a ride to the airport. But if it rains, the traffic will be bad and the probability that he will miss his flight is 0.05. If it doesn't rain, the probability that he will miss his flight is 0.02. And the probability that it rains on Monday is 24%. So notice that these probabilities of missing their flight, they depend on something else, whether or not it rains. So this is how we know that a tree diagram might be something useful for us as a tool. It's not the only way of doing this, but it's great for organizing our work. So since if he misses their flight, it depends on raining, our tree diagram is going to show that that could possibly happen. Perhaps it's going to rain, or maybe it's not going to rain. So those are the two things first that we have to consider. Because now if we know it rains, we can try and figure out what's the probability that he's on time or that he misses the flight. Same thing, if it doesn't rain, he still might be on time or he might still miss his flight. So in this diagram, we can see that these events depend on this event happening first, whether it rains or not rains. And now we can turn this into a probability tree by throwing in these probabilities. First, the chance that it rains is 24%, so we know that this is 0.24. And every time we branch out, so here we're branching out, those probabilities, one of those branches has to happen. So it always has to add up to 1. So we can deduce that this second branch right here must be 0.76 because those two probabilities have to add up to 1. The next thing we see is, okay, let's move on to the next branch. So if it's raining, so let's take a look at this branch here. If it's raining, well, we know there's a 5% or 0.05 probability that Shamil misses his flight. Well, that means there's still a 95% chance he's on time. Same thing, if it doesn't rain, now it's only a 2% chance that he misses his flight. But otherwise, that would leave him with a 98% chance because, again, those have to add up to 1. So we can see this here is a fully developed probability tree diagram where we have those outcomes and we have the probabilities for each of these branches. So let's see how this works out. So the first concept we're going to look at is that and probability. So notice here it says, what is the probability that it rains and Shamil misses his flight? So we can actually visualize this as being part of one of these branches from start to finish. So we always start at the beginning. And we're seeing, following this branch, that it's going to either rain and he misses his flight. So it rains and misses his flight. So notice that and tells us what do we do is we're going to multiply those probabilities. This is the multiplication rule, rain and missing his flight. So in this case, we see that to get down that branch is just going to be 0.24 times 0.05. And if we calculate that out, we get 0.012. So let's take a look at the second type. So the second type of problem we might look at is, it says, what is the probability that Shamil misses his flight? So notice, it doesn't say anything about if it's going to rain or not. We just want to know if he's going to miss his flight. Well, there's two possible ways he might miss his flight. Like we saw last time, it might rain and he misses his flight. So that's why we multiplied down that tree branch, rain and missing his flight. Or there's another possibility. So notice I said that word or. It might not rain still, but he still might miss his flight. So both of these branches here, starting from start to finish, end up with what we're looking for, him missing his flight. And so we need to consider both of those cases, and again, the way we do that is we add those branches together. So to get this probability, we're still going to have to multiply to go down each branch. So it's going to rain and he misses his flight, 0.05. Or, so plus, what about the other branch? Maybe it's not going to rain, 0.76. And there's a 0.02 chance that he still misses his flight. Well, let's put this into our calculator. So we have 0.24 times 0.05 plus 0.76 times 0.02, and we get 0.0272. And there's our probability. So notice if it's just one branch, it's just multiplication. If we have more than one branch, now we can add those branches together. So let's look at the third type of problem that we have here. This one's going to look the most complicated, but if we think about what's happening here, it's really not that bad. So it says, later we learned that Shamil missed his flight. So we know for sure, based off what he said, that he's missing his flight. So actually these highlighted ones are the only ones that are possible. He was not on time, so this is no longer possible. This is no longer possible, and this is no longer possible. Only the ones we're looking at. So out of those branches, notice I said the word out of those branches, we want to know what's the branch where it's raining. So that's all we're thinking about here is the branches that are given to us, that he missed his flight, where does that go? It goes in the denominator. If you think about this in terms of the notation, this is asking what's the probability that it's raining given he misses his flight. So as we've learned, that misses, again, goes in the denominator of the fraction. So I'll put the fraction down here to make it a little bigger. So let's get the probability that he misses his flight. Well, we actually already did that. It's above here. We saw that the probability he misses is 0.24 times 0.05 plus 0.76 times 0.02. Right? So that's what we found out in part 2. I'm just copying that exact line. Those are the branches that we're looking at. Now, out of those two branches, what do we want? We want the probability that it's raining. Well, which branch is the one that's raining? It's just this top one. Just the one where it's 0.24 times 0.05, right? Just this top part that we have here. So out of those two branches, what are we going to do is we're going to put that specific branch on top. The one where it's raining goes on top. 0.24 times 0.05. And this is the calculation we need to do to be able to get the probability. So it looks complicated, but if you notice again, just put what's possible, what's given to you on the bottom, and then out of those possible branches, which ones do we want? That's the ones that go on top. And so we can just put this in our calculator. So we have 0.24 times 0.05 divided by, and then that whole thing on the bottom. So I just took this entire one, put it in the bottom, and we have 0.4412. And there's our probability. Right, so we saw all three cases. Just a multiplication case where it's one branch. We saw a case where we have multiple branches, so we can add those branches together. Or we saw the one where something is given to us, in this case that he misses his flight, and that goes on the denominator, and then we choose from those denominator branches on what we were looking for. In this case, raining. That one goes in the numerator. That's it.